Right, so we're starting section 1.2 on domain and range. And so for the domain, when we're finding the domain, it is the set of all possible input values of a function. And then the range is the set of all possible output values of a function. Okay. And so the first couple, we have just graphs, and we're going to get the domain and range. On example 1, we're going to use interval notation. So we're finding the domain and range from a graph. We're just looking for the domain. We're looking from left to right and describing the x values where there is something graphed. All right. So this one is going to be interval notation for the domain. And so on the far left of this graph right here, we don't have anything graphed until we get to where x is -5. And I don't know if you can tell very well from the screen, but that is a closed circle. So for interval notation, for a closed circle, we would use a bracket. And the first x value, or the smallest x value where we have something graphed, is -5. Right? And then we have a continuous curve until we get to where x is 3. So that's going to be the larger number in the domain, 3. But if you notice, at 3, we have this open circle. And so we won't have a bracket at 3. We're going to have a parenthesis at 3. So that is the domain in interval notation. All right. And then for the range, we are thinking from bottom to top, the smallest y value where we have something graphed up to the largest y value where we have something graphed. And it looks like this graph just kind of scrapes the x-axis, and on the x-axis, the y is 0. And it does look like it actually touches the y-axis, so I'm going to do a bracket for the 0. And then the largest y value where it's graphed is where y is 2. So that's going to be our second number in our interval. And because I do have a closed circle over here on this side, I am going to include 2 with a bracket because the 2 is included because it is graphed right there. All right. And then example 2, same type of question, except this time we're going to give our domain and range as an inequality. And I'm actually going to do something called set builder notation for my inequality. All right, same thing. So I'm going to do D for domain. So set builder, you actually write a set, which is going to have this little brace symbol. And for the domain, we're going to describe what variable it's going to be. And I know it's hard to tell from this is not a perfect screen, but this actually says T. So on this one, we have a t-axis and a g-axis. And so I would say t, and then we're going to do a bar. That means such that. All right, and then we're going to give the smallest number in the domain. So the smallest x value where you have something graphed is at 2. Right? And then I do have an open circle. So the next symbol was always going to, for this situation, is going to either be less than or equal to. And because it's an open circle, it's less than. And then our t. And then we're going all the way to 8 on the right side. So I have another less than. This time, because there is a closed circle, it's going to be less than or equal to 8. All right, so that's set builder notation. And you would say that t such that 2 is less than t is less than or equal to 8. Okay, so for the range, we're going to do set builder notation. Now our range variable is g. All right. Now the lowest y, or the lowest g value, I should say, where I have something graphed is at 6. And I do have a closed circle there, so I'm going to do less than or equal to g. All right, and then we have another less than. This time it's open at 8, so it's just going to be less than 8. Okay. Now on the other domains we're going to do, I'm going to just do it all the different ways, so you just get used to seeing the different representations of the domain. So that's what you do for a graph. A lot of times you're given the function in equation form and asked to find the domain, and what you're doing in that case, you're finding the implied domain, which is all the input values for which the function is defined. So we have to start thinking about what makes a function undefined. And there are two things that make something undefined or make a function undefined. And there's two things we can't do with functions, and it is dividing by 0, because it doesn't make sense to divide something up into 0 equal parts. It just doesn't make sense. And then the other thing we can't have on the for a function is an even root, so like a square root or fourth root of a negative. Now later we'll talk about imaginary numbers where we do that, but with functions with the domain, we're only talking about real numbers, no imaginary numbers. So these are the two things that restrict the domain: dividing by 0 and taking the even root of a negative. So I'm going to tell you what you do in each case. All right? So if you end up like example 3a, you end up a situation like this where you're dividing by something that has an x, then we are going to have to restrict the domain. So if there is an x in the denominator, set the denominator not equal to 0 and solve. Okay, so we'll go ahead and do that example, and then we'll come back to the second situation. All right, and you might be able to just solve this in your head. It's fine if you can, but I'm just going to just go ahead and just do it the same way every time. So I do have this denominator that has an x. So what I would say is that whole denominator is not equal to 0, and then solve it for x. So that would mean that x does not equal 4. That's how you would describe that's one way you could describe your domain. Right? If you wanted to do that in interval notation, you would just use intervals that would include every single real number except 4. So what we would do is we would start at negative infinity and we would go to 4, but we're not going to include 4, so we do parentheses. And then you do a U for union and parentheses. We pick back up on the other side of 4 and we go to infinity. All right, so that is how you use interval notation to represent every real number except 4. And then sometimes you might need it to write it in words. And so in words, this would be all real numbers except x equals 4. So every one of those describes the domain, and you will need to be able to do all of those representations. Okay, the second situation is when you have the even root of a negative. So on B, example 1 or 3b, we have this even root right here. So it's possible what's under there could be negative. So if there is an x under an even root, set the radicand, which is what is underneath the radical. So in this case, the radicand is x plus 5. Set the radicand greater than or equal to 0 and solve. Right. So that's what we're going to do for B. So B has this even root, so the domain must be restricted. So we would say that x plus 5 is greater than or equal to 0. So x is greater than or equal to negative 5. That's one way to describe the domain. In interval notation, that's going to be all the numbers from negative 5 to infinity. Now we put a bracket on the negative 5 because we have the or equal to. All right, and then in words, this is going to be all real numbers greater than or equal to negative 5. Three ways to represent. Okay, so let's look at C. So there's only two things that restrict the domain, and it is dividing by 0 and the even root of a negative. So I don't have a division bar. I don't have a denominator in here. I don't have any kind of root, even or odd. We don't have any roots. And so this domain would not be restricted. So the domain is all real numbers. So you can represent all real numbers by that fancy R. Interval notation, all real numbers is from negative infinity to infinity. And then in words, obviously, all real numbers is just all real numbers. So sometimes there is no restriction on your domain, and those are easy to do. All right, let's look at D. We have an issue, but it's okay. We can deal with it. We have this even root here. So what I know is what's underneath that even root must be greater than or equal to 0. So to solve it, I'm going to go ahead and subtract 6. I'm going to divide by negative 2. So this is where it gets a little fishy with inequalities. If you have to divide through by a negative, you have to make sure you switch the inequality sign. So when you divide or multiply by a negative, you have to switch that. All right, so one representation of the domain is that x has to be less than or equal to 3. As long as x is less than or equal to 3, you're never going to get a negative underneath that square root. In interval notation, that's going to be from negative infinity to 3, including 3. And in words, we can say all real numbers less than or equal to 3. Sorry, that's super messy. Okay, a couple more to go. All right, so this one, we really do not care about the numerator. If your numerator doesn't have a square root, it doesn't matter. So the x minus 3, who cares? What we care about is the denominator here. So this denominator cannot equal 0. All right, now most likely this is going to be a quadratic equation or quadratic non-equation, I guess, that we can factor, and it is, okay, so we're going to get that x is not equal to negative 11, and we're going to get that x is not equal to 2. It's super important that you don't say it equals those. So these are all not equals, because those are the two things x cannot be. Those are two things that is restricted from the domain. Now this gets a little interesting to write it in interval notation, but we can do it. All right, so we are going to start at negative infinity, and we're going to go all the way to negative 11, but we're not going to include it, so we do parentheses. And then we're going to pick back up with negative 11, but we're not going to include it. And then we're going to go all the way to 2, but not include it. And then you pick back up on the other side of 2 to infinity. All right. And so in words, this is all real numbers except x equals negative 11 and 2. Okay. And then on this last one, we actually have two issues. So our numerator issue is that we have that square root and that x plus 4 must be greater than or equal to 0. Our denominator issue is that x minus 4 cannot equal 0. And so we're just going to solve these separately. So I know that x has to be greater than or equal to negative 4, and I know x cannot equal positive 4. So that we would probably want to stick an and in here to describe your domain. That's fine. In interval notation, we're going to go for x is greater than or equal to negative 4. That's going to start at negative 4. But we are not going to go to infinity because we have to exclude positive 4. So we'll go to 4, not include it, do the u, pick back up at the other side of 4, and go to infinity. Okay. And then that's going to be all real numbers greater than or equal to negative 4 and x is not equal to 4. All right, so your assignment is on page 33 through 34. I want you to do 2 through 18 even. Once you get to the ones like these examples, I want to say starting with 8, I want you to give the domain 3 ways.